Making the second year's selection. This is part 2. When the breeding plot nears maturity, the individuals should be examined and either the best and healthiest vines marked, or, if easier, the diseased vines showing weakness marked, so that they can be discarded later. Then dig each tuber unit as in the preceding year, placing the tubers from each 4 hills together at the side of the row. Each unit should then be weighed in the number of large, medium, and small-sized tubers recorded. This will enable the breeder to determine which of the original 50 tuber units selected in the first year has given the largest average yield in the 10 tuber units or 40 hill test. And this is the primary test of the value of the original selection. Following the same method as used the first year, select from the breeding plot the 50 best tuber units and preserve the tubers of each unit separately in a paper bag. The majority of the selection in this year should naturally be made from those rows which have given the highest yield. Number the tuber units selected in the second generation, 1-1, 1-2, 1-3, etc., and 2-1, 2-2, etc. In such hyphenated numbers, the first figure refers to the number of the tuber unit selected the first year, and the second number, that following the hyphen, refers to the number of tuber units elected from this progeny the second year. Thus, in the case of 2-2, the first 2 indicates that it was the second tuber unit selected in the second year from the progeny of unit number 2 of the first year's crop. In the third year, the numbers can be extended by the same principle. The tuber units selected from progeny 2-2 in the third year being numbered 2-2-1, 2-2-2, 2-2-3, etc. These numbers can be placed on the bags, and notes on weight of yield, number of tubers per unit, etc., recorded under the same number. All of the good tubers from the remaining tuber units of the breeding plot not selected should be retained for planting a multiplication plot the third year, which should furnish sufficient seed for planting the general crop for the fourth year. At some convenient period before planting time, as in the preceding year, go over the product of each select tuber unit and pick out the 10 best tubers of each for the next year's planting. Continuing selections in third year. In the third year, the 50 selections of heavy-yielding tuber units should be planted by the same method used the second year, at least 40 hills of each selection being planted. The row from each unit should be plainly labeled or otherwise marked to avoid mixing the pedigree. Treat this breeding plot as described for the breeding plot in the second year. Weigh up the product of each 4-hill tuber unit in the same way to determine which unit of the second year's selection has transmitted in greatest degree the tendency to yield heavily. Finally, select again the best 50 tuber units to continue the breeding and retain the good tubers of discarded units to plant a multiplication in the fourth year. In the third year, a multiplication plot should be planted with the good tubers from the discarded tuber units of the breeding plot of the second year. In planting this plot, the grower can use any method of cutting and planting the tubers which he thinks most desirable. This plot should give enough seed to plant a fairly large plot in the fourth year. Continuing selections in fourth and succeeding years. In the fourth and succeeding years, the selection should be conducted by the same plan as outlined above. When this system is well underway, it will be seen that each year the breeder is growing a small breeding plot, a large multiplication plot for seed, and a general crop. Further considerations. As the selection progresses, many of the strains from the original 50 tuber units will be entirely discarded. The breeder must be continually watching for the appearance of a heavy-yielding strain, and if such a strain is discovered, all of the further selection should be made from this strain. In advocating the selection of but 50 tuber units and the planting of 10 tubers only from each select unit, the writer has had in mind the reduction of the work to a comparatively simple plan, which would be better to handle larger numbers if the grower is so situated that he can take the time for it. It is, however, better to use comparatively small numbers carefully than to attempt to handle large numbers and find the work too extensive. Another method of selection has been suggested which is simpler than Weber's method, probably not as satisfactory, but which has been found very useful by many growers. It consists of planting, growing, and digging the tubers the first year, as previously suggested, but instead of weighing the hills and keeping them separate for further tests, they are chosen by means of counting instead of weighing. If the season has been an average one, the hills which have 6 or more good tubers are saved for future planting. Perhaps it may be necessary to use 5 as a standard of selection, or even 7 may be used if the crop is good. There is no attempt at pedigree breeding by keeping the different strains separate. All hills meeting the established standard are thrown together and saved for seed. The next year these are planted and grown like the rest of the field. In the fall they are dug by hand, and again the best hills by count are saved for seed. This method will gradually eliminate the poor strains and raise the average yield of the crop very rapidly. Spillman says, a potato grower in Michigan some years ago began the practice of digging by hand enough potatoes for seed and saving only those hills that had 6 or more merchantable tubers and no small tubers. When he first began this practice, only 16 hills out of each 100 dug came up to his standard. But after he had continued this practice for 5 years, the number of such hills had risen to 70 in 100. Another similar instance is found in some unpublished results secured by Dodge of the Office of Farm Management, who for several years has been teaching some New England potato growers how to select seed potatoes. The method adopted is to save for seed those hills that produce 6 or more merchantable tubers. This experiment has extended over 3 years. The first year, from 7% to 8% of hills were found that met the requirements. The second year, from 17% to 20%. This season, the number of hills which have produced 6 or more merchantable tubers has risen to 24% to 27%. Whenever pure lines or strains or varieties of potatoes are compared, every effort should be made to eliminate soil differences or other factors of environment, so that a direct test of the heredity only can be made. Potatoes are so easily influenced by environment that real hereditary differences are often covered up. Absolute uniformity in time of planting, methods of culture, spraying, and so forth are essential. The seed pieces should be as nearly the same weight as possible. Arthur says, whatever increases rate of growth at the beginning increases yield. If tuber units are being compared, they should be planted in duplicate or preferably in triplicate in different parts of the field and their production averaged. If single high-producing hills are saved for the next year's planting, one should make sure that they did not come from some highly fertilized part of the field. Preferably, they should be chosen from the poorer parts of the field when their production may be high in spite of their environment. The real test of heredity. Zavitz of the Ontario Experiment Station selected the best hills of 7 varieties of potatoes for a period of 16 years. During the first 4-year period, the average yield was 120 bushels. During the 3 succeeding periods of 4 years each, as a result of selection, the average yields were increased to 216, 218, and 249 bushels. Within the 16-year period, the methods of culture were kept practically the same, and the result is, therefore, attributed to the result of selection. Wade has conducted at the Ohio Experiment Station a series of experiments for the purpose of securing data to throw more light on the question of the value of hill selection in potatoes. In this work, starting with the same original lot of tubers, 3 strains were grown as follows. 1. Seed from high-yielding hills. 2. Seed from low-yielding hills. 3. Unselected seed. The following table gives a summary of the results that were obtained from high-yielding hills and from low-yielding hills. Table 11, summary of results from use of seed potatoes from high-yielding hills and from low-yielding hills. Variety Carmen number 3. So the source of the seed was either high-yielding hills, check rows, or low-yielding hills. In, let's see, the yield of 100 hills for high-yielding hills went in 1904 from 125 pounds, 1905 173, 1906 116 pounds, and 1904, 5, and 6 the average was 138 pounds. For check rows, the average was 110 pounds, and for low-yielding hills, the average was 73 pounds. If you look at the number of tubers in 100 hills, the average of 1904, 1905, and 1906 for high-yielding hills was 774 pounds. Oh no, the number of tubers in 100 hills was 774. In check rows, 607, and in low-yielding hills, 492. Running out of varieties. Potatoes are grown in many parts of the world where the climate and soil are very different from that of their native home. Also, all of our varieties which have been developed as a result of breeding give yields far in excess of the wild forms. The stress of uncongenial environment and large production of tubers causes most varieties to lose this abnormal, from the standpoint of the plant, producing power and to decline unless selection is constantly practiced. Disease may be partially responsible for this degeneration. Running out of varieties is often caused by repeated planting of culls and poorer specimens while the best are sent to market. Newman 1. That's Plant Breeding in Scandinavia by the Canadian Seed Growers Association, Ottawa, 1912. Okay, Newman says that in Sweden there is a potato known as the Dala, which is said to have been introduced about 150 years ago and is still one of their best sorts. The opinion held at Zvalov is that there is no period of old age in a variety of potatoes, that where suitable sorts are used and where suitable tubers of these sorts are used for seed purposes each year, the planting of the variety may be maintained indefinitely under all favorable conditions of soil and climate. The main considerations are maintenance of vigor and control of disease, and this implies careful selection of seed tubers, careful cultivation and spraying, and rotation of crops. Special emphasis is laid upon the latter point. Orton says, the same system of seed selection and treatment and crop rotation that will free the potato fields of wilt, leaf roll, and curly dwarf will at the same time not only bring under control the black leg and some other diseases, but will ensure the maintenance of the strains cultivated in their most vigorous and productive condition and be free from objectionable mixtures with other varieties. The following statement from Fruworth is representative of the opinion held by most of the European experimenters. And the real degeneration and aging of a variety which has been under uniformly favorable conditions and of which good seed is used has not been proved and is improbable. Varieties seem to differ in their staying qualities. Some have held up for 50 to 60 years, while others have passed out quickly. The old peach blow variety, which was widely grown 40 years ago, has largely run out now except in certain localities like the Carbondale region, where it has been given careful selection and is better today than ever before. Varieties seem to differ in their staying qualities. Some have held up for 50 to 60 years, while others have passed out quickly. The old peach blow variety, which was widely grown 40 years ago, has largely run out now except in certain localities like the Carbondale region, where it has been given careful selection and is better today than ever before. Another reason ascribed is that long-continued bud propagation results in an inner physiological weakening. It is difficult to see, however, how prolonged asexual propagation affects stocks injuriously. What appears to be the running out of a variety may, in some instances, be due to a change in market demands, and the varieties disappearing which do not meet these demands. For example, the old long Burbank has given place to the more round varieties, such as the Rural, and the Blue Victor has been replaced by white varieties and is now practically gone out of existence. Fruworth believes that a lack of adaptation to local conditions results in a degeneration of certain varieties. Poor attention to the selection of seed tubers is also suggested as a cause of deterioration. Fruworth summarizes the opinions of a number of German experimenters in support of these two views. East points out that perhaps the potato requires frequent crossing to keep up the vigor, and that possibly continual propagation by asexual methods causes a loss of heterozygosis. Certain plant characters are often associated together. In breeding practice, a knowledge of these associations is often valuable. If easily observable physical characters, such as color of flower or texture of skin, are associated with chemical composition, which is less easily detected, the appearance of the former is a valuable index to the existence of the latter. It has been often observed that there is a certain shade of green in the leaves, which is correlated with vigor and high productivity. If the leaves are too light green, few tubers will be produced, or if too dark, the yield is again small, or a large number of small tubers will be found, due to late maturity or possibly to disease. Correlations are especially valuable when they enable one to select out good plants in a young stage, or when they save the trouble of making elaborate chemical analysis. Only a few definite correlations have been discovered in the potato. East reports nearly all of these in Illinois Bulletin 127. There appears to be a positive correlation between yield and the following: flat shape of tuber, number of stalks to the plant, and length of the growing season. With a heavy setting of seed berries, we may usually expect a light production of tubers. No correlation has yet been found between color of the tuber and yield. Fischer of Germany, reported by East, says that round flat tubers tend to produce plants which are rather compact in habit. Cylindrical tubers produce large, scraggly plants. Round flat tubers are richest in starch. Quality is said to improve directly with an increase in starch content up to a certain point. An excessive amount of starch causes the tuber to be coarse and woody. A netted skin is usually associated with high quality. No correlation has been discovered between color of tubers and color in the stems and flowers. In certain varieties, there seems to be a coupling of characters and what appears to be a close correlation. This same association, however, may not hold for any other variety. As East points out, we ought to have a good understanding of the life history of different varieties before we draw definite conclusions as to the correlation of characters. Appearance of bud spores. Occasionally, a single bud or group of buds on a tuber will give rise to a plant distinctly unlike any others of the variety. This is known as bud sporting. Just what causes this unusual behavior we can only speculate upon. No definite cause is known. Darwin reports 3 cases of bud sporting. A tuber of the purple variety, 40-fold, had a single eye that was white. This, when planted, gave rise to a white variety. The same purple variety, in another instance, produced a white tuber which bred true. The white variety, Kemp, sported to give the red Taylor's 40-fold. Fruith reports a case where a yellow tuber gave rise to a violet-skinned form. Examples of this sort are rather numerous. Such bud sporting is not limited to characters of the tuber. Many believe that habit of vine, vigor, productiveness, and other characters may be affected by sporting of the tuber buds. By carefully examining the hills of the breeding plot at digging time, any valuable bud sports can be selected out for further propagation. Improvement by hybridization. It is hardly advisable for the practical potato grower to attempt an extensive improvement of his crop by hybridization. While the method has yielded good results in some cases, there are many difficulties in the way, and the results are very uncertain. The major portion of a farmer's potato breeding plot should be given over to tuber unit tests. If the grower feels that he can spare the time and is willing to risk a failure in his enterprise, it would be of interest and possibly a profit to attempt a few crosses between his better strains. Otherwise, this method should be left to the experiment station worker, who has the time to make the large number of manipulations necessary and who can devote large areas to the growing of the seedlings. Plants are hybridized primarily to increase their variability and to furnish more material on which to practice selection. In the light of modern Mendelian studies, we have come to look upon hybrids as recombinations of characters present in the parents. Care should be exercised to choose parents having as many desirable characters as possible. Subsequent selection should preserve those plants which combine the largest number of desirable qualities from both parents. Hybridization usually increases vigor and is often useful in restoring this characteristic in weakened strains. There are certain conditions which make the successful hybridization of potatoes very difficult. In the first place, there is a strong tendency in most varieties not to set seed. In such varieties, the flowers drop off shortly after pollination. This necessitates making a great many pollinations with the hope that a few plants will set seed. Salomon, 1, estimates that only 5% of his crosses set seed. East, 2, found it difficult to get a good setting of seed in very dry seasons. Okay, so Salomon in 1, that's Jurgen, Volume 1, pages 7 to 46. And East, 2, is the Illinois Bulletin 127. In some cases, persistent attempts have finally resulted in a successful cross where at first it seemed impossible. A second drawback is the scarcity of pollen. Many varieties produce little or no pollen and have to be crossed if we are to get sexually produced seed from them. Also, some plants produce yellow pollen, which is sterile and does not function. Other varieties rarely, if ever, flower. Most varieties of potatoes are already hybrid, and when seed from them is sown, the type breaks up into many elementary forms, most of which are of no value to the grower. This adds another difficulty to those mentioned above. Each variety which is crossed transmits a number of undesirable, latent characters which come out in the hybrids. Often the seedlings from a cross will show so many of the traits of the wild potato that none of them is worthy of further attention. Securing a valuable new variety from a cross seems in this case to be largely a matter of chance. There is an element of uncertainty in the work which is not encountered with most crops. The potato flower consists of a rotate corolla of white, lilac or purple petals, 5 green sepals, 5 anthers, and a single pistil. The style projects up through the cone formed by the closely adhering anthers. The anthers open at the tips and give out a small amount of pollen. In the daytime, the flower is in an erect position and it is impossible for pollination to take place. At night, however, the flower bends over and some of the pollen can fall down onto the stigma. The flowers open in the morning and close late in the afternoon. Fruworth says that potato flowers usually give off pollen the second day after opening and wilt the third or fourth day. The period of flowering for a single plant is between 28 and 33 days. It seems to be a general opinion that the potato flowers are only rarely visited by insects, and that wind also plays little part in the pollination of the blossoms. The first thing to be done in hybridizing plants is to decide on a definite ideal. We then choose our parent plants with reference to this imaginary type, trying to obtain plants which have as many possible of the qualities sought in the new form. Generally speaking, it makes no difference which variety we use as male and which as female parent. A great deal will depend on the nature of the varieties themselves. Obviously, we must pick for male parent a variety which bears at least a moderate amount of pollen. It is well to keep in mind a few general principles of hybridization as we proceed. First, the plant to be used as female parent should be emasculated to prevent its setting seed by its own pollen. This must be done before the anthers have matured. Second, it is safest to bag flowers to be used in crosses to prevent the entrance of foreign pollen. And lastly, the pollen should be applied to the stigma when that part is in a receptive condition. Mature potato flowers should be examined so that one may become familiar with their structure. One should learn when the anthers are mature and when the stigma is ready for pollination. Just before the bud unfolds, the flower to be used as a seed parent is open with a pair of fine pointed forceps. All the stamens are carefully removed, being careful not to break any or to leave parts of them in the flower. This must be done before the pollen is mature. All nearby flowers should be removed and buds other than those emasculated, as the flowers invariably fall off when bagged. This precaution must be omitted. The potato is not frequently cross-pollinated, Salomon, and the danger of contamination is slight. It is necessary to tag the flowers thus treated in order to know later on when to pollinate them. The tag should bear the date of emasculation and other facts of which the hybridizer wishes to keep a record. A day or two after emasculation, the pistils of the emasculated flowers should be examined. When the tips have turned a slightly darker color and look sticky, they are ready to receive the pollen. As the pollen is usually borne in small quantities, it is well to open the anthers with the point of the forceps and scrape it out on the thumbnail or onto a watch crystal. A thin film of pollen on a watch crystal will pollinate a number of blossoms. It is customary to make 2 or 3 pollinations on the same flower in order to catch it in a perfectly receptive condition. Once the ovary starts to swell, there is little likelihood of the flower falling off. The berry should be picked off when fairly dry and before it falls off and rolls away. A record should be kept of the dates of emasculation and pollination and of the parents concerned in each cross. Potato seeds should be washed free of pulp and carefully dried in the fall. If left in the pod, it is likely to decay. Each pod normally bears from 1 to 300 seeds. The seeds should be planted indoors in March or April. The seedlings are potted up when they need moving and set out in the field in June. They should be planted about 2 feet apart. Shoots are sent down into the ground from the axils of the first leaves, and it is on these that the tubers are born. As a rule, the tubers for the first year vary in size from that of a marble to that of a hen's egg. In unusual cases, single tubers have been obtained the first year, which weighed over a pound. Wilson, 1, reports a total yield of 6 pounds 3 ounces for a single seedling plant. Wilson J.H., High.and.Agri.Soc.Scot. Trance.1907, pages 74 to 92. It is often necessary to plant the tubers for another year or 2 in order to secure plants which will bear a normal crop of good-sized tubers. The tubers should be harvested separately for each plant, put in paper bags, and carefully stored until spring. Usually one is able to make his final selection the second year. But in some cases, it is necessary to plant the tubers again before he can be sure that his choice of strains is a wise one. The tubers should be planted about 40 inches apart the second year to allow a careful study of individual plants. One ought to remember that it is comparatively easy to produce new varieties of plants, and that the mere fact that we have secured new sorts does not mean that they are worthy of culture. Any new variety of plant should be distinctly superior to others on the market in at least one respect. The markets are already cluttered with mediocre varieties. Set your ideals high, and do not be content with anything which falls short of them. Also, do not waste time trying to select good qualities in strains where no such possibilities exist. Selection will not build up characters which are not potentially present. Remember, this dates back to 1917, and we've learned a lot since that time. In spite of the many hindrances to hybridization, some careful studies have been made on the inheritance of characters in the potato. We must remember, however, that in some cases at least, the material studied was not pure. Perhaps it would be safest to look upon the results as showing certain tendencies in heredity rather than as accurate character analysis. Salomon, 1-2 of England, and East, 3 of this country, have done most of the Mendelian work on the potato. A resume of their work will be given in the sections that follow. So Salomon, the inheritance of color and other characters in the potato. Salomon, a lecture on the hereditary characters of the potato. And 3 East, inheritance in potatoes. For the first one, that dates back, that's the Journal Gen Vol 1, 1910 to 11. For the second one, ROY, that's probably Royal Society of Horticulture, Journal, what is that, 38? 1912 to 1913. I guess that's pages 34 to 39. And the East, inheritance potatoes, that's AMERNAT, I don't know, American Nature or Naturalist. Maybe volume 44, pages 424 to 430 in 1910. All right, stem color. Some varieties of potatoes have pure green stems, while others have traces of purple varying from light purple to almost black. The purple seems to be partially dominant over the green. The pure greens appear to be recessive and breed true. Salomon, in 1, found that the deep purple stem color of the Congo gave a good Mendelian segregation. No ratios were given. East, I guess that's location cited, reports the following. One purple-stemmed variety, when selfed, gave only purples. 4 purple-stemmed varieties gave both purple and green when selfed. 4 green varieties, when selfed, gave only green. A pure green crossed with a heterozygous purple gave 6 purples and 7 greens. RR cross DR. Flower color. Potato flowers may be either white, heliotrope, or shades of purple. The color is usually confined to one or the other of the surfaces of the flower. In all the domestic varieties studied by Salomon, LOCCIT, I guess location cited, the color was limited to the upper surface. S. tuberosum had color only on the lower surface. In S. verrucosum, the color appeared to be present on both sides of the flower. K. East, location cited, reports 1 purple which broke up into 14 purples to 5 whites when selfed. He says that purple is probably dominant to white. Color in the tubers. The skin of the tuber may be either white, parentheses yellow, red, or purple. The flesh in like manner may be either white or colored. Purple-skinned varieties often have white flesh, and white-skinned sorts may show traces of color when cut open. Salomon, in 1, says that these colors are all due to pigments dissolved in the cell sap. East found that purples, when selfed, gave in some cases only purples, in other cases purples and whites, and in still others purples, reds, and whites. Reds, when selfed, gave either reds alone or reds and whites. Whites gave only whites. No mosaics of red and purple were obtained. The conclusion was that red is epistatic to white and purple to both red and white. Salomon, in one, selfed a red-tubered plant of the variety flower ball and got a ratio of 9 reds, 7 whites, suggestive of the action of 2 pairs or factors. He believes that chromogen, a color base, is present in all tubers. In the red tubers, he assumed the action of an R factor for color and a D factor which develops R. The second generation would then give 9RD, red, 3RD, oh, I see. All right, 3 capital R, capital D gives red. 3 capital R, lowercase d, or 3 lowercase r, capital D, or 1 lowercase r, lowercase d, those give white. The red-tubered plant which Salomon self-fertilized was assumed to be of the constitution capital R, lowercase r, capital D, lowercase d. The Congo crossed with the flower ball, heterozygous for red, gave an F1 13 black, 12 red, F1 in F1, 13 black, colon, 12 red, colon, 4 white. Salomon holds that a factor for purple, capital P, is necessary in addition to the capital R and capital D factors to give purple. He has on 4 different occasions united strains bearing white-skinned tubers to get colored types. This may be a case of factor interaction similar to Bateson's case of complementary colors in the sweet pea. Solanum tuberosum seems to have an inhibitor in the formation of purple in the tubers. Flesh color. Very little work has been done on this character. Salomon notes that the color of flesh is inherited independently of skin color. He says that colored flesh is apparently due to the action of one pair of factors. Shape of tuber. Both East and Salomon found roundness recessive to other shapes. Round potatoes bred true in all cases. Salomon found that long tubers bred true for long axis, but often varied in diameter and hence in shape. Many oval-shaped potatoes were found to be heterozygous and to break up when selfed into round, oval, and elongated. The kidney and cylindrical-shaped tubers have about the same length of axis, but seem to have different factors determining diameter. The reference for Salomon RN is the inheritance of color and other characters in the potato, JURN dot, I guess that's journal, GEN dot, volume 1, 1910-1911. All right, depth of eyes. The deep eye is a recessive character and breeds true. Shallow eyes are dominant over deep eyes, but often not completely so. Sterility. Salomon 1 finds that a tendency towards sterility is dominant over a fertile condition of the pollen. In a cross of record, no pollen, cross, flower ball, parentheses, abundant pollen, the F1 generation gave 12 pollen-bearing plants and 20 with no pollen. One of the sterile, for pollen, F1 plants crossed with the male parent used above gave 19 pollen-bearing to 20 non-pollen-bearing. This is practically the 1-to-1 ratio which we should expect to get from a cross between a heterozygous and a pure recessive. Stolon length. The stolons on which the tubers are borne are unusually long in the species. S. commersoni and S. verrucosum, often reaching 6 feet or more. In the domestic varieties, the stolons average 9 to 12 inches. Very long and very short stolons breed true. Intermediate stolons break up into various lengths, suggesting the action of multiple factors. Salomon, 1, thinks there may be 2 or perhaps 3 pairs of factors involved. That's Salomon, A Lecture on the Hereditary Characters of the Potato, Royal Society of Horticulture, Journal 38, pages 34 to 39, 1912 to 1913. All right, plant habit. Salomon 1 states that upright and prone habit of plant are due to the action of one pair of factors. A duplex condition of the factor for uprightness gives a perfectly upright plant. Heterozygotes, capital A, lowercase a, are upright at first, but droop toward the close of the season. Prone plants have the constitution lowercase a. Both prone and upright plants bred true to type. Intermediates gave a ratio of 1 upright to 2 intermediates to 1 prone when selfed. Shape of berry. The seed berries of domestic varieties of potatoes are round. Those of the wild species tend to be long. Salomon concludes that 1 pair of factors is involved. He believes the long berries to be due to a duplex dose of a factor for length. When the length factor is simplex, a heart-shaped berry results. The double recessive factor gives round berries, which breed true to shape. The references for the section, I'll just sort of summarize them. East, a study of the factors influencing the improvement of the potato, 1908. That's in the Illinois Bulletin 127. East, inheritance in potatoes, American Nature, maybe, 1910. Fraser, the potato, Orange Judd Co., New York, 1-185, 1901, Breeding and Selection. Fruworth, C., Die Zuchtung der Landwirtschaftlichen Kulturpflanzen, Volume 3, Berlin, 1905. Newman, Plant Breeding in Scandinavia, Ottawa, Canadian Seed Growers Association, 1912. Potatoes would be this book probably, page 168 to 182. Salomon, R.N., The Inheritance of Color and Other Characters in the Potato, Journal GN, Volume 1, 1910 to 11. Stewart, William, Potato Breeding and Selection, USDA, Bulletin 195, Professional Paper 1915, pages 35. Wade, Results of Hill Selection of Potatoes, American Breeders Association, ANN.REPT. Volume 3, 1907, and Weber, H.J., Methods of Breeding and Improvement of the Potato Crop, Cornell Farmers Reading Course, Bulletin 43, 1909, pages 753 to 768.